Hello everyone, welcome to the Equation Web. Today we'll be doing another trigonometry problem, so let's start with the question. Today's question will focus a lot on trig identities and summation as well. So summation notation with the symbol sigma. So today's question is, compute the following sum: tan of 1 degree plus tan of 5 degrees plus tan of 9 degrees, so on until tan of 177 degrees. So I'll give you guys some time to try and solve this question and maybe figure out some patterns that are going on with the degrees. So here we have our series from tan of 1 degree all the way up to tan of 177 degrees. And to find the amount of terms in this series, we can plug it into an arithmetic series formula. So a sub n is equal to a1 plus n minus 1 times d. So d is our difference from each term. N minus 1 is whatever number term the term before it is. So if the term is number 4, n minus 1 would be term number 3. A sub 1 is our first term, and a sub n is the term that we already know or we want to find. So we can put 177 as our a sub n. We can put 1 as our a1 because it's tan of 1 degree. Then 4 is our common difference. So as you can see, between every term, the amount of degrees is increasing by 4 degrees. And we have our arithmetic series formula filled out. And if we solve this, we get that n is equal to 45, meaning that there are 45 terms in the series. So this trig identity will help us solve some things. So tan of 180 degrees minus theta is equal to negative tan theta. We will use this soon. So for example, we know that 177 is 180 minus 3. So we know that tan of 177 degrees is equal to negative tan of 3 degrees. This doesn't help us cancel out anything yet, but we do know that 45 terms are in our series, and we can use this to write a function or something for our series. So if we take theta equal to 1 degree, 5 degrees, so on, we can think of these as the roots of our function. And since we have 45 terms, so between the interval 0 degrees to 180 degrees, there have to be 45 solutions. Now we can take tan of 45 theta to be the function of our series. So now let's plug in these values and check. So we get tan of 45 times 1 degrees, which is just 1, and the same for 5 degrees and 177 degrees, which means that this is a function that can represent our roots. Now we can use binomial theorem to rewrite tan of 45 theta. So this is what comes out. From k is equal to 0 to k is equal to 22, the function negative 1 to the power k times 45 choose 2k plus 1 times tan of to the power of 2k plus 1 theta over from k is equal to 0 to k is equal to 22 of the function negative 1 to the power k 45 choose 2k times tan to the power 2k theta. That represents tan of 45 theta. And next, a simple part, we can just rewrite tan of 45 theta as 1 because we know that for every single root that we have in our series, it equals 1. Now, after solving out all of the summations and simplifying, we get this equation, which is very long, and you can read it right here. Now, that equation was really long, and we just need the answer to our series. So we can use Vieta's formulas to find that. Now for any polynomial in the form x to the power n plus a sub n minus 1 times x to the power n minus 1, so on, is equal to 0. Negative a sub n minus 1 is equal to the sum of the roots of the polynomial. And we know from our previous equation that a sub n minus 1 was negative 45. Now let's multiply that by negative 1, and we get that our answer is 45. So the sum of our series that went from tan 1 degree all the way to tan 177 degrees is 45. So our question was, compute the following sum: tan of 1 degree plus tan of 5 degrees plus tan of 9 degrees, so on, up till tan of 177 degrees. The answer to this question is 45. The sum of the series is 45. Thank you for watching, and make sure to like and subscribe.